So as far as how to calculate and measure current, and there's some other things that we're going to measure as well. As with many other things we've talked about, there's a variable for current, there's a way to measure it, and there's an equation to calculate it. So the symbol for current is capital I, right? Which I don't really understand the history behind that. There probably is a reason why they use I. They didn't use C for a different reason. Current does start with a C, but we're going to use C for something different. Regardless, the symbol for current in our equations, or I should call this really variable. The variable for current is I. The unit for current, the unit of measurement, the way that we measure is called the ampere, or sometimes we just shorten it to amps. And an ampere is defined as the flow of 1 coulomb of charge. Remember, a coulomb is the unit for charge, and the unit for charge is coulomb. I just said the same thing twice. The flow of 1 coulomb per second. So that's if we have a unit of a stretch of wire, and I mark one arbitrary place on it. If 1 coulomb of charge flows past that point in 1 second, that means the current, the amount of flow, is 1 amp. And it's really useful to think about current. I mean, think about where you've heard this term. We've heard it with current in a river, in a stream, with the flow of water. And the flow of water is a really, really good is a really good metaphor to understand how electric current flows as well, right? So we can measure water current by measuring the amount of water, the volume of water that flows past a given point per unit time. Well, we measure electric current the same way, the volume or the amount of charge that flows past a given point per unit time. And it's called the ampere. We measure amperes with an ammeter that looks like this, or at least we used to. This is really old school. You can probably tell that. Nowadays, we use these things called multimeters. You may have seen one of these. Maybe you have one of these in your house. They have multiple functions. They will measure voltage, resistance, all kinds of things that these things will do. Very, very useful. But this is how we measure current. The equation for current is I equals Q over T. I is our variable for current. Again, the unit is A. Q is the variable for charge. We talked about that with electrostatics, right? So that shouldn't be new. Q, lowercase q, is the variable we use for charge, and remember the unit is the coulomb, and then t, lowercase t, is time, as it has been all year long, and time is measured in seconds. So I equals Q over T. Current equals charge divided by time. This equation is useful because, again, it shows us what current is. It's the amount of charge that passes at a given point per unit time. So here's a really simple yet huge example of how to use this current equation. If a lightning strike has a charge of 10 coulombs and has a current of 10,000 amps, really big current, really big charge, how long does it take to strike? Now, first of all, every problem you read, you should be using your own personal experience to try to determine what kind of answer you should get. Lightning doesn't take very long to strike. All right, so we should expect a small answer here. If you give something really big, you did something wrong. So the equation that we're using is the current equation we've just used, and I know that because it asks for time. How long does it take to strike? And they give you charge. 10 coulombs is charge, which is Q, right? These are things you got to begin to kind of memorize. Charge is Q. And they give you I, which is current. Current is I, and it's measured in amps, A, right? So 10,000 A is I, it's current. So I know that this is the equation. I equals Q over T. We're going to plug the numbers in. I is 10,000. The current goes there. Q is 10, so we're going to substitute 10 in for Q, and T is what we're solving for. Whenever you're solving for the variable in the denominator, the first thing you have to do is cross multiply, or at least multiply by that variable on both sides. So we're going to multiply by T on both sides. That gives us a new equation. 10,000 T on the left equals 10 on the right. Because we got rid of the T on this side, we basically moved it to the other side in the numerator, not in the denominator anymore. And now to solve for T, we're going to always divide by the number next to what you're solving for if you're going to divide. And again, the reason we're dividing is because these two next to each other are multiplied. So we're going to do the opposite. Going to divide by 10,000 on both sides. Gets rid of 10,000 here. 10 divided by 10,000 is our calculation. And 10 divided by 10,000 turns out is 0.001, or about 1 millisecond. So this should be right? How long does it take lightning to strike? About that long. Right? If you get something really big, and a lot of people will here, because they'll just go the other direction. They'll do 10,000 divided by 10. Right? They'll flip these because they won't know to multiply by t on both sides, and they'll just like divide by 10 somehow arbitrarily. 10,000 divided by 10 gives you 1,000. 1,000 seconds is way ridiculously too long for lightning to strike. So just some common sense is in order for solving these problems. Here's another very simple example that's a little bit smaller. How much charge, right? So let's think about charge. It's asking for charge. The variable is Q. So we're looking for Q. How much Q would pass through a light bulb in 5 seconds if the current delivered to it is 0.7 amps. Remember, current, the variable is I. So again, we're looking at the same equation. I equals Q over T. How much charge? We're looking for Q. They're asking us to solve for Q, right? So let's plug in what we have. We know the time and we know the current I. So 0.7 gets substituted in for I. 5 gets substituted for time. 0.7 equals Q over 5. To solve for Q, this is division, so we're going to do multiplication, which is the opposite. Multiplying by 5 on both sides gets rid of it over here, leaving us with only Q. And 0.5 times 7 is 3.5. So 3.5 coulombs is the answer to this question. So there's a couple simple examples of how to use this I equals Q over T equation.